Hello and welcome to this series of lab tutorials in the sphere of identity and access management. So we are going to start with very basic tasks such as creating user accounts and assigning different super user privileges to this account, or different accounts would going to be having different privileges as we assign them, and see how this takes effect in the system to add more advanced concepts. So you want to stay tuned, and for this series of labs, we recommend that you use Alma Linux or Ubuntu, CentOS, and Debian. So those are the recommended operating systems. And for each lab, we are going to be using different operating systems for the various labs. So welcome again, and boot up your Alma Linux so we can start right away. All right, so we're going to start right away by creating some user accounts. So I want to have super user privileges first. So I'm now in my root access. So I want to create three accounts. Let's create Lionel. We're going to also equally create Caitlin, and of course we are going to create Maggie. Okay, so now we are going to assign the user passwords with the various accounts. So let us start with Lionel. So and now we are prompted for Lionel's account password. So oh, sorry, say password not match. All right, so let us put assigning password for Caitlin. Okay, let's do the same for Maggie. All right, so you notice that I started typing sudo user at Lionel, and then later on I stopped using sudo. That's because I'm already in root access. I'm already super user. All right, so to be able to manipulate the user account privileges or assign different account privileges to these various users we've created, we are going to check the sudo as configuration file. So to do that, you say sudo v sudo, and there is it. Now, what we are going to do is that first things first, we want to make sure that Maggie has full access, full privileges over system storage, over storage management. Why, let's say Kathleen, we limit Kathleen to have system control only over HD, over secure shell, and then let Leone have full system control, whether be it over storage or secure shell. So let's go right away. So the first thing is that we are going to tap on I to be able to edit or write or type something into this configuration file. So the first thing we're going to do is that we are going to look for the storage. It starts up. So we're going to come down, and then we look for where we see networking. We pass that. Now we're going to come to what's wrong? So we're going to come looking for storage. And we have to uncomment the first, the storage alias. Okay, so that's storage. You can comment that. And then we come down to default, and where we find root. So we are going to add the various accounts here. So let's say Lionel, we're going to put in Lionel, and let Lionel have full system control. So the next thing we're going to put in cabling. All right, and Caitlin, we said we are going to limit Caitlin to just be able to do this over secure shell. So that's our system control via and then lastly Magi. Sorry. Magi is only going to do that through storage or over the storage alias. So let's escape to save that. WQ that. Good. So we are good. Now let's test how this manipulations on the configuration file or this editing of the configuration file has affected the system and the users therein. So let's switch to Lionel. Okay, we are now in as Lionel. So we want to see, is Lionel able to have full system privileges like super user privileges? Is Lionel able to have that? All right. Good. Lionel is in as root. All right. Now let's exceed that. Let's see if Lionel can do system control. Let's check his system control status over secure shell. Lionel is in. All right. Let's exceed that again. And no, let's go back to Lionel. Let's see if Lionel has full super user privileges over storage. Okay, oh, it shows that Lionel has that. Now let's switch to Caitlin. We are in as Caitlin. Let's see. Caitlin is a global super user. Says no. She's not allowed to execute as super user to have full super user privileges as a local host in a local domain. So let's see if Caitlin can be able to have super user privileges, full super user privileges over secure shell. Yes, it's active. She can do that, everything over secure shell. And let's see for storage if she has super user privileges, full super user privileges over storage. She's sorry, she's not allowed to execute that as root in this local host. So let's clear, and then we switch to Magi. Okay, we are in as Magi. This Magi is super user. Oh no. Let's see if Magi has super user privileges over SSHD. All right, so check our status. Sorry, she's not allowed. Let's check our file system storage. Okay, so she's allowed to have super user privileges over this management of storage. Now let's come to the conclusion with these takeaways. When you create user accounts in Linux, first thing you must think about is assigning passwords. After assigning passwords, that is not enough. You must be able to determine which of these accounts should be able to have super user privileges. That is, which of these accounts should belong to the super user accounts or to the SODWAS alias. So we'll conclude with this. When creating accounts, you assign passwords. That's normal, but that's not enough. What you must do is determine among which of these accounts must have the super user privileges by assigning them to the sudoers group or to the sudoers alias to ensure that these accounts can do or have control over specific or all of the system resources or services. So thank you and see you in the next lab. Hello and welcome to yet another lab in identity and access management. So we are going to go right away to lab 2. And in this lab, what we are going to be doing is that we are going to be invalidating the sudo catch credentials. That's we are going to be resetting the timer for every user account that accesses super user mode or something like that. So what we are going to do is that we are going to be resetting this timestamp, and resetting simply means that one, the credentials you use to access the super user mode, we are going to clear it off. So each time you want to access super user or each time you have to run a super user command, you'll be prompted for your super user password. So that is what we are going to be doing right away. So let's get on. Okay, so we are going to start by first of all reading the first account we created. So we want to now initialize or invalidate my catch credentials I use in accessing the super user privileges in my account. So what I'm going to do is that I'm going to type see how that works. So sudo fdis. I'm not asked for my password because this password or my credentials I use in accessing my super user, they are already initially stored in my catch. So I want to invalidate that. I want to clear that off. So to clear that off, I'm going to type this command. Once I do that, it looks like nothing changes, but let me type the same command again. You see, I'm asked for a password. If I should type any sudo command, let's say sudo system ctl status, let me see my secure shell status. It's still open because that has been cached. But if I do this and I clear this, now if I should do the same command now, I'll be asked for my password. But now, so let me do the same command. So notice that when I cleared the cache and I invalidated the cache credentials, I'm asked for my password or my credentials again. So now we want to make sure that this is not left open always. So each time I have to access super user privileges, I must put in my password, even if I'm just on putting in the previous command. Okay. So what I'm going to do is that we are going to have to view this sudo configuration file, and then we are going to go down to default, and in default we are going to add some default timestamp to ensure that this thing is not always left open. Once you're a sudoer, you must not remain in sudoer. Once you're in the sudoer mode, you must not remain in the sudoer mode. You should just get in, and then quickly the system removes you automatically by initializing the timestamp. Okay, so what we're going to do is that let's go to sudo vsudo to be able to. Okay, so we are going to come down to where we see timestamp. We're going to look for find we'll find that in the default specification. Okay, so that's it. So we are going to insert something here on that default specification. So we are going to put default time, default time span, and underscore timeout equals 0. And then we are going to see that let's exceed. Okay. So now we want to see how this affects our system. So good. If I say sudo and tables, so you realize now that in this case, each time I want to do is access is run a super user command, I'm prompted for my password. All right. Whereas in the previous case, it wasn't like this. I had to run. In the previous case, I had to clear this cache credentials manually. But here we've edited the configuration file specifically in the default specification section, and we've added the clause that sets the default timestamp to 0 seconds. So each time you have to run a super user or sudo command, you must be prompted to put in your password. And after putting that password, you want to do another super user command, you'll be asked that particular password again. So that is how you can reset the sole dual timer in Linux. All right, thank you, and see you in the next lab. Hello, welcome to lab 3. And in lab 3, we are going to be learning how to create encrypted home user directories with add user command. And in this lab, we are going to be working with Ubuntu 24. So if you even have right down onto Ubuntu 20, you can still do the same stuff. So all you have to do is boot into your virtual machine, log into your user account, and so right away, let's go to terminal. And what we are going to do is that we are going to install the encrypt utils. The encrypt utils. All right. Okay, already have it installed. So what we're going to do is that we're going to use this encrypt utils to create an encrypted user home directory. And the way to do that is that you have to, the command is sudo add user encrypt dash home, and then let's say we create the user Cleopatra. All right, so we create the user Cleopatra. It says that okay, let's give Cleopatra a new password. Now it's asking us for a name. We're going to put Cleopatra. Number, we can say 1, 2, 3, 4. Work home 1, 2, 3, 4. The home phone 1, 2, 3, 4. And then, okay, is this information true? Yes. All right, so now let's see if there is that home directory for Cleopatra. And that's the command to view the home directories. All right, so we have it there. CCMC has 16 folders in the home directory, with Cleopatra has 2 folders. Okay, so what we are going to do is that let's log in as Cleopatra now. Okay, we are in as Cleopatra. So we want to see the passphrase that we use. The passphrase that was used, or that is used to that will be used to unwrap this account. Okay, so want to see the passphrase. Okay, yeah, so password. Good. So that's the passphrase. So each time we want to maybe delete this account, this passphrase will be asked. All right. And the way to access this passphrase is that I must know my home, the user account password, and also I must be able to, have this passphrase. Okay. So that is it. And okay. So like I said, uh, that is the way you create an encrypted home user directory. And then also you need the passphrase, which we saw above, to be able to delete that home user directory. All right. And to access the passphrase, you must be able to log into the particular user account, use the password to unwrap that passphrase, view it, and then you can copy it and use it whenever you're prompted for it in case you want to delete the user account. All right. Thank you and see you in lab 4. Hello and welcome to lab 4. In lab 4, we are going to be setting password complexity criteria for passwords and the quality of passwords we want to exist in our system. So basically, in this lab, we're going to be using the LeapPalm quality password quality package. So you have to have that installed, and the way to install it, you just come to your virtual machine and you say sudo apt install LeapPalm-pw quality. Okay, it says package already installed. So now what we want to do is that we want to set the minimum length for our password. We want to set it to 19. So the way to do that is that I'm going to say vi etc/security. This is where the configuration file for password quality is found. And I'm going to say pw quality.cnf. And while I'm here, we are going to uncomment the min length and set it to 19, and then we're going to save that, and then we see how it affects an account. Okay, so let's create a user account. Let's say create a user account Goldie. So we're going to say user add Goldie, and then we now going to add a password to Goldie and see. Okay, so let's say we use a password. Let's use Turkey lips. Okay, it says password is shorter than 19. Okay, so here we want to modify the password complexity criteria even more. And what we want to do is that we want to set the min class to 3 and set the max class repeat to 5. Min class simply means that we want our password to have a minimum of 3 different character classes included in it. There are different character classes such as capital letters class, you have the small letter class, we have the numerical class, and of course the special character class. So one that our passwords should always have a minimum of 3 of these classes included in it. And then max class repeat simply means that we want our passwords to not have a maximum of 5 consecutive characters of the same class. Okay, so the way to do that is that we are going to have to the security, the password configuration, and then we open that. So we are going to come down to min class, press I to insert, delete the uncomment that, and then we're going to set the min class to 3, and then min class, max class repeat, we set that to 5, and then we uncomment that. So, and then we can save the file. Boop, we are in. So now what we are going to do is that we are going to modify the password of uh, let's say Goldie, which we created above. And the new password, let's try a password that has more than five consecutive character classes. All right, so it tells you that, okay, now let's try to use just two character classes in our passwords, respecting the max class repeat. So we're going to try that. All right, since password contains less than three character classes. All right, now let's try for, of course, the min length. All right, consecutively. So if you respect the min class repeat and the three character classes. All right. If you respect the max class repeat and the three character classes, it tells you the password is that. So that is it. We have set the password complexity criteria for the user account Goldie, and we saw how this affected how the passwords of the account Goldie or passwords generally in our Ubuntu operating system should look like. All right, thank you so much and see you in the next lab. Hello and welcome to lab 5. In lab 5, we are going to be seeing how to set user account expiry data and password expiry data. So to do that, we are going to be using, of course, working on CentOS 7. If you have a ARMA Linux, you can use it or any Linux distribution. So all we have to do is now go to our virtual machine and get our hands on the deck. Okay, so what we want to do is that we want to create a user account Samsung, and we want the other account to expire on the, let it expire 90 days from the day we are creating it. That let's set it to expire maybe on the 30th of June 2025. So to do that, we are going to create a user Sam and set the expiry data for Sam's account, and we'll call it his password. So user app -e. Now we send the expiry data to be on the expiry date to be on the 30th day of the 6th month of 2025, and the name of the account should be Sam. And good, that's Sam. Let's see if that is taking effect in the system. All right, so we see that Sam's account details, last password change 27th of April, password expires will never expire, password inactivity period never, account expires on the 29th of June, that's the 30th day of the month of June 2025, minimum number of days with password between password change is 0, maximum of days between password change is 9,999, number of days of warning before password expires 7. So that is it. Now we want to do something more specific. All right, so we want to be able to force Sam to be able to change his password each time he has to log in into his account for the first time. All right, so the way to do it is that we are going to say sudo Sam, and we want to set a new password. All right, this is just for exercise. Okay, now type the next command, sudo password Sam. Okay, it says password change. Now we want to switch to Sam to see if that has taken effect. So switch user Sam. So you're required to change your password immediately, administrator enforced. So the current password and then the new password. Oh, all right, let's do that again. Sorry. So you see, we had already set on password complexity criteria. That's why it's disturbing the system. So let's follow the rules. Uh, okay, so we successfully changed the account password for Sam at the first login. So we're now in as Sam. Okay, so want to see Sam's account status. So to do that, you just simply say sudo change Sam. Good. So that is it. You see accounts password the first time it shows that his password will never expire. Okay, now we want to set Sam's password expiry and account expiry data. So what we want to do is that we want to set a minimum of 5 days for Sam to wait before he can be able to change his password again. And we want to set his account or his password to be active for just 90 days. I want to set his account password that it should never be inactive for more than 2 days. And also want to set a 5-day warning period. So the way to do that is that we're going to say sudo change minus to 5. That's 5 days he has to wait before he's able to change his password. Then minus capital M, 90 days his account is active or valid for 90 days. And then we want to set the inactivity to 2 days. That this account should not be inactive for more than 2 days. And we want to set the warning period, that's 5 days to the expiry days, to the expiry dates. Okay. And then we want to set that to the account Sam. Now, if we see check the account status for Sam, we are going to see that okay, it has changed. So right now he has a waiting period to change his period of waiting period to change his password for 5 days. He has maximum of 90 days to change his account password, and also 5 days for which he's going to be receiving warnings or alerts concerning the status of his password in his computer or on his account. So I think we have come to the end of lab 5, and see you in the next lab. Hello and welcome to lab 6. In this particular lab, we are going to be using the pound passwords API to verify our own passwords. In other words, we want to be able to verify the password we want to use in our system to see if these passwords have already been compromised in such a way that we are limiting or mitigating the possibility of dictionary attacks. So to do that, we are going to use the pound passwords API to verify the input password. So it's a whole procedure, but it's simple. So what we're going to do is that we are going to create a bash executable file that takes as parameter our passwords and verifies it against hash values that are on the pound passwords API file. So to do that, we are going to have to install the curl curl package. To do that, just have a sudo apt install curl, and you can do that from Ubuntu, from ARMA Linux, or CentOS. Is still the same thing, but specifically the command I gave was for Ubuntu only. So to do that, we have to power up your virtual machine right away, and there we go. So what we are going to do is that we're going to see if curl is already installed. So sudo apt install curl. Oh, sorry. All right, it says curl is installed and it's running the latest version. So what we are going to do now is we're going to try to see if curl can reach the pound passwords API. So to do that, we're going to say curl https API dot pound passwords.com/. Now we want to only check hash values for a particular range that has this consecutive initials 21 BD1. Oh, sorry, the letters have got to be in caps. So, boom. So we are connected to the Pound API now. So let me clear this. And then what we are going to do is that now we are going to open this file. I already have it in my computer in my home directory, but I'll put the link to the file in the description so you want to check it. So I'm going to go straight to the file, and it's a bash file. Let me show you what's inside. So this is it. I want to copy this and I'll close it. I'll come back to my terminal. Okay, so what I'll do is that I would want to nano a file. I want to create a new file and I'll call that file password verifier or password checker dot shell. All right, I'm inside. So I'm going to now paste the file, the content from the bash. So let me explain to you what this command does. This command, what it does is that it just asks the candidate, it just asks you for your password, or you pass a parameter to the file, to the shell script, to the bash script, and what it's going to do is that it's going to hash that password that you sent, and then it's going to do a prefix and a suffix comparison to the passwords that are found in the api.poundpasswords.com in that particular range. So when it finds anything that matches that particular hash of the prefix and the suffix, is going to tell you that, hey, the password is compromised. Otherwise, it's going to tell you your password is okay for use. So I'm going to save that and I'm going to quit. So now I have to see where is my file. Okay, it says password checker.shell. All right, let me clear that. So I'm going to change the mode. I'm going to make that file executable. So let me go into super user mode. Okay, I'm in a super user. So the file is in my directory. I want to change the mode to make it executable. So u plus x and password checker.shell. So boom, if I check it now, I see it has execution. It's not executable. Password checker. There you go. The X is now appended to it, and that's why you find out up here. It's now in green. Okay, so clear that. Now we want to pass password parameters to that. So what we're going to do that we're going to say okay, so we want to try different passwords. So let's try turkey lips. It's going to verify. It's going to connect to the api.poundpasswords.com /range 21bd1 and verify if there's anything that matches that password. If there's something that matches it or not, it's going to give us a result based on that. So let's just be patient. Connection is quite slow here in Bamenda. Okay, so it is finished checking and gave us a result that, hey, the candidate password is compromised, meaning it is not a good password choice for our system. So we want to try another password. Let's see, I love you. Give it some time. Candidate password is compromised. Let's try turkey leaves in all small letters. Sorry. Okay, password is compromised. Let's try this name. Let's see. What? Even the name Paul B has been compromised. Wow. So as you can see, this is a powerful tool you can always use to verify if a password has been compromised already before you start using it. So you can save yourself from already known passwords that have been compromised, such a way that an attacker cannot perform a dictionary attack on your system or your infrastructure. So thank you and see you in the next lab. Hello and welcome to lab 9. In this lab, we are going to be looking at special files in the Linux operating system, specifically the SUID, that's set user ID, and the SGID, that's set group ID files. Now, why are these files particularly important? These are important because it's one of the routes through which one can be able to gain elevated privileges over particular files. So what SUID simply stands for is simply a bit that is appended to a file that permits a user to execute that file with the privileges of the owner. So you inherit the owner's privileges by executing that particular file. All right. And this will be very useful when it gets to situations where you don't want to grant full root access to a particular user, but the user can have escalated privileges over a particular domain, a small domain of the system, such as maybe your user in the system has the privilege of changing or modifying their own passwords without having root access. All right. So the SGID bit is simply a bit that is appended to a directory that allows the user or allows files within that directory or within that group to inherit the permissions of that group. All right, rather than the users of the primary, rather than the users primary directory. So I get into a particular bucket, and that bucket is having a couple of people there, and I get to execute their files within that bucket without changing my directory, without changing or moving from my own bucket into theirs. So I just send my hand, get the file, use it for what I want, and I run it as someone who is within the user group. All right, and get my stuff done. Now, these two concepts are particularly important, especially when it comes to security or mitigating attacks within the Linux system, because through this one can easily escalate privileges. So imagine I can now search for SUID files within the system. When I find these files, what I do is that I can run those files or I can execute the file, with the owner's permission. And this now permits me to probably, for example, change the password of an account. All right. So I do not know your password, but I can change it because I can, through SUID bit, be able to run that file with, escalated privileges. So in this particular lab, we want to start by putting up a carrying machine. And what we want to do is we want to search for the particular files in the system that has the SUID and the SDID bit, that is the set user ID bit and the set group ID bit. So the way to do that is that we have to go in as to type in sudo find slash 6000 S and this.
ID underscore SGID underscore files. So what we're basically doing is that we want to find all of the files in the system that has this this particular pseudo is appended to it, either being by virtue of the file belonging to a group of users or being owned by a particular user that has appended the user ID on that particular file. So we're going to put in a sudo password and wait for it to set your entire file system and then stores that. Okay, so when that is done, executing, what we are going to do is that we are going to switch into another user account. So there you go. Alright, so now we are into another user account. What we're going to do is that we are going to now create some new file, some random file, and then append the user ID, SGID to this file using 4755. So let's go ahead. So say touch on file. Okay, so now what we're going to do is that we're going to switch into another user account. So let's switch into this account. So we are into this account now. So I'm going to create some random file and then append my the user ID to this file. So sudo. Sorry, let me increase the font size. So I'm going to say sudo touch some underscore file dot shell. Good, so the file is there. So, alright, so this is our file we created. Okay, so now what we're going to do is that we're going to set the user ID bit for this file. Four, seven, okay, so that's good. So if you want to see this 37 file, you just have to say sudo ls some underscore file sh and boom. So that's it. So it has now the user ID bit for the person that created this file. So which is a root user. So what we want to do is I want to search now the entire system to find out all the files that have the SEDUID bit and compare them. In this current system, which for which we just created a new file and we appended the SEDUID user ID bit on the file. So we want to now do a search in the system to find out if there's any difference, if there's a new file, and let me display that new file. Alright, so what we're going to do is that we're going to run a new search and then store the result of that search in this text file like we did above. So let's say sudo find 6000 minus ls. We want to save this in this file. We want to give it a new name, so let's call it 2. Give it some time. Okay, now that I've done searching, so we want to see the difference between this is the difference between the two files. So we're going to do that. And as you guys see, Sorry, that's it. So it tells us that the difference is this file, which we are created as root in the ccmc2 account. So we find out that this is the file. And okay, so this is the way you go ahead to find out the, no- the files in your system that has this SUID and SGID bits appended to it, and it's very useful in the case where you want to do some rapid sorting to be able to find a way to get into the system. So thank you and see you in the next lab.
Hello and welcome to Lab 10. In Lab 10, we are going to be setting and managing user attributes. So sometimes in Linux systems, modifying, editing user attributes could really be overburdensome. So there are two specific commands that permits us to assign or manage user attributes in Linux operating systems. So the first is the change attribute that permits one to be able to modify or edit the file, or the list attribute, which permits one only to be able to read. You can read, you can view, but you can't modify, you can't edit, you can't do anything to it. All right, so we are going to go right away and boot up our virtual machine to get on with this lab. So in this particular lab, like I said, we are going to be setting or editing our file attributes. So the first thing we're going to do is that we are going to create a file for which we are going to be testing this particular attribute on. So the first thing we want to do is that we want to say create a new file. So we say touch some underscore. Let's say we say touch uh, demo.txt. Okay. So we want to say we want to pass something to it. So we want to say echo. Hmm, this is a test file, and we want to name this. We want to pass this parameter, this text to the test file we've already created. So go to, we cut the file. Um, good. We see the text is inside the file. So now what we want to do is that we want to see, want to list the attributes on the file. So to do that, we say ls attr, then we specify, we give the name of the file. So we say it's p demo, and boom. So that's the those are the attributes. So currently the file is null, it hasn't got attributes appended to it. So right now the first thing is that we're going to do is that we are going to set the append only attribute. What that means is that you can only add to the file, you cannot override what was there, you cannot delete it, you can only add to it. So what we're going to do is that we're going to say sudo change attribute, then we're going to add a plus a, and then we see the file is pem demo, and then oh sorry, good. So if we should list the attributes of the file, sorry, good, we see that the append only is there. Now that we've enabled the append only uh, attribute to the file, let's test to see how it works. Okay, so I'm going to try to pass some um, new text to this file. So say overwrite uh, sorry, that's wrongly spelled, overwriting attempt, and then I'm going to say let this be passed to the file pem demo. I hit that. Well, it says operation not permitted pem demo.txt. All right, let me try to do it as a sudo. Maybe it's because I did not do it as a sudo. So let me try that. Say echo, say overwrite, writing attempt, and then I want to pass it to the file pen demo. Okay, this is permission operation not permitted pen demo.txt. Okay, so let me try to delete the file now and see. Remove rm cannot remove pem demo.txt operation not permitted. Okay, now let's try to use maybe it's because of the privilege level, so let's do it as a super user. So we can say pem demo. Well, operation not permitted. All right, so that is it with the append only attribute. So it only permits you to add something to the file. All right, so if I go ahead and test this now, let me test it, and I say I can only pass the text to it. I can say echo. Okay, append din test, and then you use the double greater than sign and you specify. What this double greater than sign simply means that do not override, do not pass it as an entire parameter, simply just add it below. All right, so well, it has gone. So if we cut pen demo now, oh sorry, okay, so let me clear that and then I show you perfectly. If I cut p e m, okay, you see this is a test file and appending test, so it shows that it worked actually. So now the next attribute we are going to be setting is the immutable attribute. This is simply the I attribute. All right, we can set it and we can remove it. So the first thing is that we are going to first of all remove the the append only attribute. So to remove that, you simply say minus a and we specify the file. Okay, so we remove that now. So what we're going to do is that we're going to now add the immutable attribute. So plus I, and we send it to the file. We say we append it to this file. Good. So all right, so there is it perfect. There is clear the I attribute. All right, now let's try to modify or to rename the file or something to see if it works. All right, so what we're going to say sudo echo yeah, overwriting attempt. This is permission not operation not permitted on that file. Okay, let's just try to do a simple echo. Permission not operated, operation not permitted. All right, so now let's see if we can even do a simple appending. Let's see if we can append. All right, okay, this is operation not permitted. All right, now let's try to see if we can even delete or move the file or to rename it. So let's see if we can delete rm pem demo. All right, this is cannot remove pen demo, operation not permitted. Let's see if we can uh, change the name. We can yeah, to let's say rename the file underscore file dot txt. It says cannot move pen demo to rename this, operation not permitted. So we've assigned an attribute to this particular file that makes this file not editable by any other person. Not even the super user can do that. So now let us remove the immutable attribute, yeah, on this file. So to remove that, you just need to change attribute, sorry, and we say minus I, and we specify the name of the file, or you have to do that as a super user, as a sudo. Okay, now we remove that. So if we say list attributes on the file, all right, so that is it. Okay, so that is it. We are just from seeing how attributes can be assigned to a file, specifically the append only attribute, and the immutable attribute. With the append only attribute, we saw that you can only add content to the file. You cannot overwrite the file. You cannot modify the original content, but you can add something to it, but you can reduce. And we saw that with the immutable attribute, you cannot even do anything to the file. You can delete, you cannot overwrite the file, you cannot add new text or something to the file. And this puts the file in a very safe state where the actual user or the owner of the file has full exclusive privileges over that file, and nobody can rank up with, let's say, privileges over that of the owner of the file, or over that user which has the immutable attribute appended over his or her file. So we also saw that it was literally not possible to rename the file, or to either delete it, or to create a hard link to the file. All right. But however, we were able to see that you could create a soft link to the file. The soft link or hard link is simply an alternative way of going to the same file but using another file path. All right. So that was it for lab 10, and see you in lab 11. Hello and welcome to lab 11. In lab 11, we are going to be creating a shared user group directory. Now, why is this important? This is important because sometimes in an establishment, users or workers need to collaborate, that need to have a shared directory where they have access to their various files. So in this lab, we are going to see how we can create a shared directory. We set ownership over this directory, and then we also define permissions and access control list over the various files created or owned by the different users in this particular group of users. All right, so if you're ready, I want you to put up your virtual machine. I prefer we do it either on Linux, Kali, or Linux Ubuntu. So right away, let's get to work. Okay, so let's get to work. The first thing we're going to do is that we're going to create a group called the sales group, and the way to do that is we're going to say sudo um, group sales. All right, we already created that. Sorry, I did that, but I wasn't recording my screen, so I had to redo it again so you see the commands if it worked or not. All right, so let's see if that group actually exists. Well, since it's already there, it shows that it exists, so it's their sales group. All right, so the next thing we want to do right now is add users to this particular group. So what we're going to do is say sudo user add, and then we say minus capital G, and we want to add Mimi. Yeah. Oh, sorry, it's a syntax error. I was supposed to say group. When you say big G, you have to specify the group. So the group is the sales group, and then we want to add a user Mimi in the sales group. So we want to add another user, Mr. Gray. All right, we say Mr. Gray, and we want to add the last user, Mommy. Okay. Now we have these three users added. We want to now set their password. So we're going to say sudo pass wd mini, and well, since you want to be fast on this lab, we want to just put something busy. All right, we're going to do the same thing for Mr. Gray. uh, okay, I want to do the last thing for Mommy. Okay, I want to do the same thing for Mommy. And good, we now have that password created. And what we want to do right now is that after we've assigned these passwords, we want to now create a shared directory, and we want to assign permissions, we want to assign privileges and access control list over the files that are in this shared directory. All right, so we want to say sudo and make d, and want to specify sales. All right, so we have that. So now we want to say sudo change owner. All right, and we want to say nobody, sorry, nobody, and want to say sales slash sales. So what this command will simply do is that it changes the ownership of the sales directory to the sales group. All right, so it's the entire group that has this directory, and no one person can delete it in this group. Everybody has ownership over this particular directory. Sorry, that was a syntax error. Okay, so you don't have to keep a space between nobody and the first sales. All right, so the next command I want to do now is that I want to say sudo uh, shown 3770 slash sales. All right, so this 3770 would enable set group ID so that the files that are created in this group will inherit the attributes of the group. All right, so 3 will set the group ID, 7 will grant full permission to the group, and 0 prevents access by others. Let me take that again. 3 would set the group ID so that files that are created inside this directory will be owned by the group. And 7 will inherit the attributes of the group. All right. Now, 7 will grant full permissions to the group, and 0 will prevent others from accessing it. Okay, so we've done that. And now we want to see, we want to list the group, the shared directory permission. So the way to do that is we're going to say list minus ld and then slash sales. All right, so there is it. It shows clearly 73770. All right, now let's clear this. And okay, so now let's start creating and managing files in this shared group directory sales. All right, so we're going to switch as Mimi. All right, so now we are in as Mimi. We are going to go to the sales directory. So go to sales. We are in as sales. Let's confirm. Now we want to create a file, so we're going to say sudo echo this file belongs belong to Mimi, and then we want to name that file mimi underscore file dot txt. All right, so let's say sudo nano mimi underscore file dot txt. Good. So this file belongs to Mimi. All right, we close that. Let's cat Mimi underscore file dot txt. Boom. Okay, we see that. So the file is there. Okay, that's a mimi underscore file dot txt. All right, so now Mimi is able to create this file because the set group ID bit is set for this file automatically once Mimi created this file, because she created the file in the sales directory. So now we want to change the access control. We want to change the permissions on this file. All right. Okay, so who gets to read, who gets to write and delete or whatever, or execute on this file. So what we're going to do, we're going to say change mode. Sorry. This change mode 600 mimi underscore file dot txt. So we're going to sudo change mode 600 mimi underscore file dot txt. The 600 here signifies that only the user can be able to write or has write privileges, write permissions over this file. So now what we want to do is that we want to set the file access control list on Mimi's file. So the way to do that is a set facl minus m, and we want to specify um, who gets to be controlled over this. All right, so we want to say that Mr. Gray should only be able to read, should only have the read permission over the file mini underscore file dot txt. All right, so this means that Mr. Gray only has read access to Mimi's file. All right, and this will not affect other users. Okay, now, oh sorry, we have to do that as a sudo. So we say sudo set facl minus m for the user Mr. Gray, and let the permission, or yeah, let the permission be read only mini underscore file dot txt. Good, so we have that. All right, so let's now switch as Mr. Gray and see something. All right, good. We are now in as Mr. Gray. So we want to do is that I want to go to the directory, the shared directory, so the sales. So we want to cut mimi underscore file dot txt. All right, you see this file belongs to mimi, so we can only read. Okay, let's try echo appending something to Mimi's file. Okay, and we want to say the name, the file should be, sorry, file.txt. All right, cannot create Mimi file.txt, permission not, or permission denied. Okay, so on the ls we want to see, yeah, so it shows that only Mimi can do that. Only Mimi has the user ID for that. All right. Now, so we see clearly here that Mr. Gray can read the content, can view the content, but cannot change it, cannot modify it. All right, due to the restrictions on the file. So now let's try to see um, what how this affects mommy. All right, so let's sue. Okay, now that we are in the sales directory as mommy, all right, now what we want to do is that we want to see if we can view Mimi's, the content of Mimi's file. All right, it says permission denied. All right, okay, now we want to see if mommy can also delete Mimi's file. So we'll say rm minus f file mimi underscore file dot txt. So all right, permission denied. All right, this brings us to the end of lab 3, and we saw how it is possible for us to create a shared home or shared directory, which in this case we created a shared directory sales, and we added users to this group, all right, that owns the directory sales, and we changed the group ownership to the group, that nobody owns the group owns the group. So we set the group ID on the shared directory sales, and then we went on to create different files for the different users, and also gave different privileges and define ownership, likewise access control list on this particular file for the account Mimi. And we saw how this affected what Mr. Gray and Mommy, though they are in the same group as collaborators, what they could do on Mimi's file and what they could not do on Mimi's file. All right, so thank you, and that brings us to the end of lab 11. Ciao ciao. Hello, welcome to lab 12. In lab 12, we are going to be looking at how to manage security enhanced Linux, that cell Linux, and we're going to look at how these can be used to enforce security or access control, access management in Linux operating systems. So Linux simply is like for long, it's a security enhanced Linux, which controls how processes or services interact with files and other services, ensuring that only authorized actions are performed within a system. So it is also very important to note that wrongly configured or misconfigured cell Linux settings can cause access errors, and so the understanding of how you manage the cell Linux policies is expedient, is really needful. So without wasting so much time, let's go straight to our virtual machine and get to work. All right. So for this particular lab, I recommend we use Fedora or any Fedora or CentOS or Arma Linux. Okay, so we'll be using Fedora. Let's go. Let me make that big. All right, so we are here in Fedora. So the first thing is we're going to do is that we're going to install the Cell Linux package. All right, so if you're on CentOS 7, you should rather use sudo yum. If you're on Arma Linux, you should use sudo dnf. All right, and all right. So if you're on Fedora, it's sudo dnf. So it's sudo dnf dnf install httpd set troubleshoot. Sorry, set trouble set tools policy core utils. So let's give it some time to download. So briefly, what this command will do is that it's going to install the Cellulose package and also the policy utilities. So it's going to install two stuff: the troubleshooting tools that set troubleshoot, and it's also going to install the policy tools or utilities, which is policy core utils. All right, so we are in the northwest and the connection here in the house is poor. So I'm just going to cut it to when you finish it, then that down. Okay, so the installation is finished, it's done already. All right, so what we are going to do is that we are going to now restart the audit login. Um, this login, audit login, restarting it on ensures that Cell Linux logs uh, capture events for debugging. So what it's going to do is that it's going to activate the Cell Linux logs and now begin to keep specific data which concerns fixing errors for errors that are needed for or that is needed for troubleshooting in chat. All right, so what we're going to do is say sudo restart, sorry, sudo service audit the restart. Okay, so everything is restarted. Now, what we are going to do is that we are going to start the Apache web server uh, for operating system. So the way to do that is say sudo system control enable. I want it now httpd. All right, that is done. So the next step, we're going to say sudo firewall command, and I want this permanent, and I want it to be able to add uh, service HDH hypertext transmission protocol. So uh, HTTP, and good, that is activated. And then what we're going to do is that we're going to now say sudo firewall um, command. We want to reload this so that it refreshes everything. Good, so it will load is successful. Now, the reason why we have to activate Apache, which is the HTTPD, and configure the firewall is to allow HTTP traffic to flow. All right, so let's verify if Apache is running. So it's sudo system control status HTTPD. All right, so it's up and running. And now what we're going to do is that we're going to, oh, sorry, let me clear that. So now what we have to do is that we have to create a web page and check if the cellulose levels appear on this web page. All right. So the way to do that is that we're going to say sudo nano var slash www sorry www html slash index dot html. Now we've just created a new HTML file. So what we are going to do is that we're going to now pass in some text to this file. So we're going to say HTML, go down, and then we're going to see, sorry, head, title, let it be cell Linux, right, test page, and title slash head, and then we want to go down, we want to say body, and then we're going to say this is a test of cell Linux, and then we're going to close that and say this is the body, and, and then we finish with the HTML header. So what we've done here is that we have just created a simple HTML test page to verify the cell Linux enforcement. Okay, so we're going to save that, and we're going to. Okay, so now that we've successfully created a test page, so what we want to do now is that we want to verify the correct if the test page you've created has the correct security levels. Normally, the correct security level should read uh, you should have this line. You need httpd underscore sys underscore content underscore t. So Let's see that. Sorry. Um, okay, so we have that there. We have HTTPD content underscore T. All right, so it's there. Now, what we want to do is that we want to be able to locate our machine's IP address, and then we go to the browser and we put in this IP address to verify how this currently looks like. So I'm going to say IPA, and I'm going to copy this. This is the IP address of our virtual machine, and I'm going to come to the browser and I will put this. All right, so as you can see, it reads here, Share Linux test page title that. So we're going to close that. And what we're going to do right now is that we are going to modify the file again, that we're going to change the security levels on this index.html file we created. So the way to do that is that we're going to say sudo um, change condition minus t tmp underscore t space. I want to specify the particular file, and the HTML file. So boom, we good. So let's see the new security levels if they are changed. Let's see the security levels that exist now. All right, so it reads something different. It reads T underscore T, it reads TMP underscore T. So this is the wrong or poor security level on that web page. So what we're going to do is that we're going to still go to our web browser, and we are going to paste that IP address there and see what it says. Okay. Um, sorry. All right. So right now it shows us forbidden. So that tells us that we've enforced that configuration via um, the cell unit. So the next thing we're going to do is that let us restore the previous conditions for this file for the cell unit configuration we just created. So sudo restore con, and we're going to see v, and then we specify the file. All right. Okay. So we say we relabeled HTML index.html from on confined object. These two on confined object HTTPS system. Good. So the restoration was completely done. And if we go back to our web browser and we reload our web browser, simply reload our web browser with the same IP we used the last time for our machine. Wow. So you see, it shows sell a new test page titled that. All right. So that was it for the 12 lab. And in this lab, we successfully configured the Cell Linux troubleshooting and quality tools, and we diagnosed access violations, and we also learned how to restore the proper security levels. So Cell Linux enforcement is really important and essential for security over web servers and web applications. So you want to get it rightly configured, have the right security levels for you to be able to access services or servers online, and be able to have data transaction between these two entities, that's your machine or a particular application, your machine and web server. All right, thank you and see you in the next lab. Hello and welcome to Lab 13. Thus far, I hope you found this series of labs interesting and easy. All right, quite illustrative and illustrative enough. So in lab 13, we are going to be looking at C Linux booleans and ports. All right. So what we're going to be doing basically is that we want to modify C Linux policies by managing the allowed ports and boolean settings for service control. All right. So what we are going to be seeing clearly is that how strict Linux is and why we have to sometimes modify the rules in order to allow services to function correctly. All right, so we are going to adjust the Linux policies to grant the Apache to grant Apache access to a custom port. What is Apache? Apache is simply the open source HTTP service that on which most websites uh, are run from. All right, it's owned by the Apache Foundation, Apache Software Foundation. So, without wasting so much time, can we go to our Fedora or Amalin to CentOS and get this done with? So, good. So we are in. So the first thing we want to see is the allowed Apache ports that are available. All right. So we're going to see sudo cmanage port minus L, and then we are going to say grep http. All right, so this is simply going to list all the ports that are currently permitted for hypertext transfer protocol. All right, traffic. So by default, normally Apache would use 80 and 443. All right, so we want to ensure that the port 80 is listed before we continue on. All right. All right. So this is HTTP. This is HTTP port, and you see we have 80 there. We have 443. All right. So um, that means by default it's enabled. All right. So the next thing we want to do is that we want to change the port on which the Apache listens on. All right, the Apache listening port. So what we're going to do is we're going to say sudo nano etc. So we want to modify the configuration file for Apache. httpd.cnf, and here what we want to do is I want to find the line that says listen 80, and then we want to change it to 82 and see what happens. All right. So there we go. So we want to change it to 82, and we save that and exist. So basically, we've instructed Apache to listen rather on port 82 and not 80. All right. And what we are going to notice is this. All right. So after changing the port, now let's restart Apache. So we're going to say sudo system control restart httpd, right? And all right, so it says job for httpd.service failed because the control process exceeded with an error code. See system control status this service and journal this. All right, the reason this failed to restart is because we changed the authorized listening port. All right, so if we did not change the authorized listening port, normally Apache would have restarted. All right, so if you want to view the system log to verify the restart error message, you just say sudo tail space -20, that's it on the screen, -20 slash var slash log slash messages, and there you're going to find the error messages for the particular restart failure. All right. So now it shows the cell Linux denial messages, restart failure messages. Okay, preventing Apache from using the port 82. This is because Apache normally was not authorized to use port 82. All right. So now we want to authorize Apache to use port 82. So what we're going to do is say sudo say manage port minus a minus t http underscore port or t minus b tcp and finally say 82. All right, so what this means is that now if we restart Apache, it's going to restart because we've just authorized port 82 to be on reports through which our machine can access the Apache server. All right, so let's try restart and see. All right, so we're going to sudo system control ct restart httpd. Good. So it returns no failure now, meaning it successfully restarted. Therefore, port 82 is an authorized port for Apache right now. So if you want to verify that, you can say sudo manage sudo say manage port minus L, and we want to grab that. All right, we grab that's a search to see if that to see the attributes or the various well, files that have HTTP on it. All right, so let's see that. Okay, so now we have HTTP port underscore T and we have 82 now because we authorized it above. All right, so if we clear that and we say let's if we clear that and now if we say we want to restart oh sorry. Okay, so it's fully restarted Apache, meaning 82 is now a pre-configured port through which our machine can communicate with Apache. All right. Okay. So now what I want to do is I want to see how we can remove some custom port authorization. All right. So we want to remove 82. Okay. So what you have to say is sudo say manage port minus d. So um, minus a to add and minus d to remove. All right. Minus t http underscore port underscore t minus p and then tcp. We want to remove the port 82. Okay, so it went successfully. All right, so 82 is no longer an authorized port. It has been deleted from the authorized ports or list of authorized HTTP ports to enforce our selling restrictions. So if we want to confirm that, we can either test a restart or we can do the grep. So we should sudo say manage. All right, minus L, wanted to list it, and I want to find the service. I want to find the word, the string HTTP. Oh, sudo say manage. Sorry, I was supposed to use manage port. Good, so we have it there. 82 is no longer found among the list of the authorized ports. So that means we've successfully removed it. Okay, So what we want to do is that we want to now revert Apache's configuration to take it back to the same state we left it. So we're going to say sudo nano um, etc slash ht silicon dot sorry ht. Okay, so now what we want to do, we want to go and let it rather listen on port 80 instead of 82. Remember, we changed it from the start. So we put it at 80, we save the file and we close it, exit. And that brings us to the end of lab 13. And in this lab, we successfully modified the Cell Linux Apache or ports or the Cell Linux port rules, allowing Apache to temporarily have access to port 82. Okay, before we brought it back to the default security settings. So this is very important because ports that access gateways or access windows or holes through which one can access and transfer or share data, or receive and send data. So we want to make sure that only the authorized services are using the authorized ports. I want to make sure that by default, the ports should be well configured and or well allowed or should be accessed by the correct or proper services at the proper time also. All right, so see you in the next lab and stay well.